In this video, we're going to cover questions 15, 16, and 17. All three of them are very similar and require us to use the rational root theorem and synthetic division in order to find the real zeros of some polynomial. Okay? So this one says identify all the real zeros of this third power polynomial. Okay? And we don't have anything to start with except the polynomial. And so the rational root theorem says that we need to identify some possible roots, some possible zeros of this polynomial. And they come from the factors of the constant at the end. Well, the factors of 10 are 1, negative 1, 2, negative 2, 5, negative 5, 10, and negative 10, okay? And now the other thing we have to do is we can make fractions out of these numbers based on the factors of the coefficient, the lead coefficient. But the lead coefficient here is 1, so Q equals 1, and therefore all of these possible zeros up here are all going to be over 1. So we're only going to be dealing in whole numbers. We won't have to deal with any fractions at all. And that's good news. So here's what we have to do is we have to test each one of these one at a time. We've got to test 1, then negative 1, then 2, then negative 2 using synthetic division. And this is going to remind us of question 14 from the last video where we were able to identify whether a number was a root of a polynomial if its remainder is equal to 0. So that's what we're looking for here. We're going to start with 1. We're going to put 1 in a half box, and we're going to put these numbers as our synthetic division. We have a 1, a 2, a negative 13, and a 10. So 1, 2, negative 13, and 10. I'm trying to write small because I have a lot of numbers. I have 8 numbers to try up here. So I'm going to bring down the 1. And remember, what I'm looking for is I want to see if I get a remainder of 0. If I get a remainder of 0, then 1 is one of my real roots, and that's good news, okay? So bring down the 1. 1 times 1 is 1. 2 plus 1 is 3. 3 times 1 is 3, and 3 plus negative 13 is negative 10. Negative 10 times 1 is negative 10, and negative 10 plus 10 is 0. And sure enough, I've got a remainder of 0, and that means that one of my real roots is x equals 1. That's one of my answers, okay? Now let me show you what I do here. Because I found one of them, I'm actually now going to start working with the bottom numbers here. I'm no longer going to work with 1, 2, negative 13, and 10. I'm now going to start working with 1, 3, and negative 10. And what I want to show you is when you're down to only 3 numbers at the bottom like this, you now have a quadratic, right? So if we were to interpret this as a quotient, we started with a third power polynomial, so this is now a second power polynomial, okay? So this is going to be x squared plus 3x minus 10. And so the thing is, this could be factorable. And if it is factorable, then we can find the other 2 zeros without doing any more synthetic division. Or we can do the quadratic formula. And that's what I'm going to do. We can do a equals 1, b equals 3, and c equals negative 10. I'm going to go ahead and do the quadratic formula, and that's going to guarantee that I get any more real zeros that remain, okay? So I'm going to do x is equal to, remember the form is negative b plus or minus the square root of b squared minus 4ac all over 2a. Okay, so I'm going to do x is equal to negative b. Well, b is 3, so that's negative 3 plus or minus the square root of b squared, so that's 3 squared, minus 4 times a is 1, times c is negative 10. Okay, negative 10, all right, all over 2 times a is 1, okay? So this is going to give me negative 3 plus or minus the square root of, well, 3 squared, that's 9. Negative 4 times 1 is negative 4, and negative 4 times negative 10 is positive 40. So that's plus 40 all over 2 times 1 is 2. And so we can rewrite this as x equals negative 3 plus or minus the square root of, and 9 plus 40 is 49, and the square root of 49 is 7. This is over 2. So we have negative 3 plus or minus 7 all over 2. So we're going to do negative 3 plus 7. So negative 3 plus 7 over 2, Well, negative 3 plus 7, that's 4. And 4 divided by 2, so 4 over 2, 4 divided by 2 is 2. And therefore, another one of our real roots is 2. And notice that 2 is in our list. If we had just continued with synthetic division, we would not, well, I don't know about negative 1. This could actually give us negative 1. But we would have gotten a root at 2. So we can say another one of them is x equals 2. And now we're going to do negative 3 minus 7. So negative 3 minus 7 over 2. Negative 3 minus 7 is negative 10. Divided by 2 is negative 5. And so our third root is negative 5. And look, it's in the list, negative 5. So x is equal to negative 5. Now the fact that we came up with whole numbers for our other two roots means that this thing over here was factorable. X squared plus 3x minus 10 is factorable. We could have just factored it into x minus 5, x plus 5 times x minus 2, and that would have given us x equals 2 and x equals negative 5, which is what we came up with the quadratic formula. So we could have factored it, but we did the quadratic formula, but either way we got all of our zeros. And that's it for number 15. Now we'll go on to number 16. All right, we have the same question here. Find all real zeros of this polynomial. But this polynomial is a fourth power polynomial. Okay, so we're going to make our list of all the factors of 36. I'm not going to be able to fit them up here because there's more than 8 of them. I do have good news though. Our lead coefficient is 1 again, and therefore we only have to do integers. We don't have to do fractions. Okay, so the factors of negative 36 are going to be negative 1. And, oh, I forgot 1. 1, negative 1. 2, negative 2. 3, negative 3. 4, negative 4, not 5, but 6, negative 6, not 7, not 8, but 9, negative 9, and then 12, negative 12, and then 18, negative 18, and then 36, and negative 36, okay? We're not going to start with the big numbers, we're going to start with the small numbers, but we got to do synthetic division. If we can get it down to only 3 numbers, we might be able to factor it. So we're going to start with a 1, okay? And our numbers are 1 and 5 and negative 5 and negative 45 and negative 36, okay? So 1, 5, negative 5, negative 45, and negative 36. Now, for this question, you may actually need a sheet of scratch paper, because if you wind up having to do like 7 of these, you're probably not going to fit them all in this space. Okay, we're going to bring down the 1. 1 times 1 is 1, plus 5 is 6, times 1 is 6, plus negative 5 is 1, times 1 is 1, plus negative 45 is negative 44, times 1 is negative 44, plus negative 36 is like negative 80. All right, so our remainder is not 0, and therefore 1 is off the list. Okay, now we'll try negative 1. We're going to try 1, 5, negative 5, negative 45, and negative 36. I'm going to try and squeeze it all in here, fit as many as I can in this space. Bring down the 1. 1 times negative 1 is negative 1, plus 5 is 4, times negative 1 is negative 4, plus negative 5 is negative 9, times negative 1 is 9, plus negative 45 is negative 36, Negative 36 times negative 1 is positive 36, plus negative 36 is 0. We have found one of our real zeros, negative 1. So we can say that x equals negative 1 is one of our real zeros of this polynomial. Now that we have found one of the real zeros, instead of using 1, 5, negative 46, and negative 36, we can actually now use 1, 4, negative 9, and negative 36 instead. So when I test my next number, which is going to be 2, so this is a good one. Now when I test 2, I'm going to use these 4 numbers instead. So I'm going to do 2, and then I'm going to use 1, 4, negative 9, negative 36. I'm going to draw a line, bring down the 1, okay? And 1 times 2 is 1 times 2 is 2. 2 plus 4 is 6. 6 times 2 is 12. And 12 minus 9 is 3. 3 times 2 is 6. And 6 plus negative 36 is negative 30. That is not 0. The remainder is not 0, and therefore 2 is not one of my factors. So now I'm going to try negative 2, okay? So I'll come up here, and I'm going to put negative 2 in a half box. I'm going to use 1, 4, negative 9, and negative 36 again. 1, 4, negative 9, negative 36. Horizontal line. Bring down the 1. 1 times negative 2 is negative 2. Plus 4 is 2. 2 times negative 2 is negative 4. Negative 4 plus negative 9 is negative 13. Negative 13 times negative 2 is positive 26. Plus negative 36 is negative 10. So once again, we do not have a remainder of 0. Therefore, negative 2 is not one of the factors. Okay. So now we are going to try, let's try 3. So try 3, half box, 1, 4, negative 9, negative 36. Draw a line, bring down the 1, times 3 is 3, plus 4 is 7, times 3 is 21, minus 9 is 12. 12 times 3 is 36. 36 plus negative 36 is 0, and therefore 3 is one of our roots. So x is equal to 3. So we've got 2 of our 4 roots. Now the bottom is down to 3 numbers. And that means that this is going to be x squared plus 7x plus 12. And we could do the quadratic formula where a is 1, b is 7, and c is 12. But we're going to try, hopefully we can factor this thing, okay? Are there 2 numbers that multiply to 12 but add up to 7? Sure enough, 3 and 4, okay? So 3 and 4. Oops, positive 3 and positive 4. So 3 plus 4 equals 7. That's right here. And 3 times 4 equals positive 12, which is right here. Okay, so our 2 numbers are positive 3 and positive 4. So this factors into x plus 3 times x plus 4. We're going to set that equal to 0 and solve. Now we have to set this one equal to 0 and this one equal to 0. So we're going to do x plus 3 equals 0 and x plus 4 equals 0. Subtract 3 here, subtract 3, and we get x is equal to negative 3. That's one of our solutions. Subtract 4, and we get x is equal to negative 4. And so, look, we have 1, 2, 3, 4 real zeros. We have found all the real zeros because there can only be as many as 4, and we are done with question 16. All right, last one here, number 17. We're going to find all the real zeros of this polynomial. It's a 4th power polynomial, so there can be up to 4 of them. We're going to use the rational root theorem to start off. Unfortunately, our lead coefficient is not a 1, it's a 3. Therefore, we may have some fractions. Our P is 420, and so we're probably not going to make a conclusive list, but let's start a list, okay? We know that 1 and negative 1 are factors of 420. It's an even number, so we know 2 and negative 2 are factors. 42 can be divided out of it, and so we know that 42 A factor of 42 is 3, and so is negative 3. We know if we were to divide this, I can tell you with certainty that 4 is a factor of it, 4 and negative 4. And because it ends with a 0, we know that 5 and negative 5 are factors of 42, or 420. 6 is a factor because 6 is a factor of 42, and 42 is a factor of 420. So 6 and negative 6. And since 7 is a factor of 42, we know that 7 and negative 7 are possibilities as well. I don't know about 8. Let's see here. 8 would go into 40. 8 is not a factor. So let's stop at negative 7. We'll see where it goes. If we don't find them in here, then maybe we'll go further. I do want to make some fractions though. So we got to the factors of 3 are 1 and 3, and all of these numbers are already over 1. They're whole numbers. Now I want to do all of these over 3. But I'm not going to do all of them over 3. Let's just start off with maybe 1/3, negative 1/3, 2/3, and negative 2/3. Okay? 3/3 is 1, 6/3 is 2. We might want to try 4/3, and we might also want to try 5/3. Okay, but let's see how it goes. So we'll start with 1. We'll do 3, and this one could take a little while, so don't get discouraged. Just keep going. Negative 24, negative 27, 276, and 420. Okay, and we're going to draw a line. Bring down the 3, times 1 is 3, minus 24 is negative 21, times 1 is negative 21, plus negative 27 is negative 48, times 1 is negative 48. Negative 48 and negative 276 is 228, times 1 is 228, and this is not going to be 0. This is like 648, and therefore 1 is not a factor. 1 is not a factor. Now let's try negative 1. Negative 1, do 3, negative 24, negative 27, 276, and 420. All right, so draw this, bring down the 3, times negative 1 is negative 3, plus negative 24 is negative 27, times negative 1 is 27, minus 27 is 0, times 1, negative 1 is 0, plus 276 is 276. Whoops. Let's see here. Times negative 1 is negative 276. Well, this is like, I don't know, 140 something maybe, 144, I think. But it's not 0, okay? So I know negative 1 is off the list, okay? Now let's try 2. 2, 3, negative 24, negative 27, 276, 420, and draw a line, bring down the 3, times 2 is 6, minus 24 is negative 18, times 2 is negative 36, plus negative 27 is it's negative 63, times 2 is negative 126, plus 276 is 150, times 2 is 300, and 300 plus 420 is 720. But it's not 0, so 2 is off the list. Now we'll try negative 2. Negative 2, do a 3, negative 24, negative 27, 276, 420, draw a line, bring down the 3, times negative 2 is negative 6, plus negative 24 is negative 30, times negative 2 is 60, minus 27 is 33, times negative 2 is negative 66, plus 276 is 210. 210 times negative 2 is negative 420, plus 420 is 0. We got one. We got one. Negative 2 is one of our zeros. So we're going to say x equals negative 2, and I'm going to put a box around it. Okay, we found one. This is good news because now we can use these numbers down here at the bottom. Okay, we can use 3, negative 30, 33, and 210. And I noticed something interesting here. Let's write this out. So this now becomes 3x to the third minus 30x squared plus 33 plus 210, okay? We can actually factor a 3 out of this. We can take a 3 out and then we can just do what's left on the inside with whole numbers. I'm not going to do that because I know it's a little confusing, but I want you to know that that would make things easier. Let's move on, however. Let's move on to 3. Okay, let's try a 3, and we'll do 3, negative 30, 33, and 210. All we're doing is, remember, because we found one, we're now going to work with these 4 numbers. It's going to make it a little easier. Bring down the 3, times 3 is 9, plus negative 30 is negative 21, times 3 is negative 63, plus 33 is negative 30, times 3 is negative 90, and plus 210 is 120, not 0, therefore 3 is not one of our numbers. Now let's try negative 3. And I know what you're thinking. You're like, this is a really long process. Yes, it is. These are some of the hard problems. There are plenty of easy problems. These are the hard ones. But it's at least it's the same procedure. It's not like you don't have to do a lot of thinking on this, okay? You just have to do it. Bring down the 3 times negative 3 is negative 9, plus negative 30 is negative 39, times negative 3 is positive 117. 117 plus 33 is 150, times negative 3 is negative 450, plus 210 is negative 240, not 0, therefore negative 3 is out. Now let's try 4. 4, 3, negative 30, 33, and 210. Draw our line. Bring down, oops, that's not a good place for the line, make some more room. Bring down the 3, times 4 is 12, minus 30 is negative 18, times 4 is negative 40, negative 72. Plus 33 is, let's see, negative 39. Negative 39 times 4 is like negative 156. Plus 210 is 54. Not 0. So 4 is not one of our numbers. Now we'll try negative 4. This is why you may need some scratch paper. 3, negative 30, 33, and 210. Bring down the 3, times negative 4 is negative 12, plus negative 30 is negative 42, times negative 4 is 168, plus 33 is, let's see, 998, 201, and times negative 4 is negative 804, plus 210 is like 600 and something, but it's not 0, so negative 4 is not one of our numbers. Now we'll try 5. 5, got a 3, negative 30, 33, 210. Okay, bring down the 3, times 5 is 15, minus 30 is negative 15, times 5 is negative 75, plus 33 is, let's see here, negative 45, negative 42, negative 42 times 5 is negative 200, negative 210, that's awesome. And so we found one. Remainder 0, so 5 is one of our zeros. So we can say x equals 5 is one of our roots. We found 2, and now we have 3. This is now a quadratic. We have 3x squared minus 15x minus 42. And if I set that equal to 0, I can now do the quadratic formula. I can say a is 3, b is negative 15, and c is negative 42. Okay? Let's go ahead and do that. I'm going to make some space here. This is where my scratch paper is going to come in because I don't have enough room now in the box. I will want to still write my answers in here. I need some room for the quadratic formula. Okay, let's get rid of this. I'm going to leave this one here, the one that I did. All right, good. Now, I'm going to do x is equal to, let's see here, x equals negative b, and in this case b is 15, so that's negative 15. Okay. Plus or minus the square root of negative 15 squared which is going to be 225, minus 4 times a, which is 3, times c, which is negative 42. Now I'm going to go ahead and do this in the calculator. I'm going to grab a calculator. See, over 2 times a is 3. Okay, so I'm going to do what's under the radical. I'm going to do this right here in a calculator. Okay, here's what I'm keying in. I'm keying in, I got my calculator open, and I'm keying in parenthesis negative 15 close parenthesis squared. Okay, minus 4 parenthesis 3 close parenthesis negative 42 close parenthesis. Then I'm pressing enter, and what I get is 729. And so this winds up being, so negative 15 is positive 15, so I have 15 plus or minus the square root of 729 divided by 2 times 3 is 6. And the square root of 729 is 27. So what we have here is x is equal to 15 plus or minus 27 over 6. Okay, so if we do 15 plus 27, that's 27, 37, 42. That's 42 over 6, which is 7. So this is one of my roots, is 7. And that's actually in the list, 7. So one of my roots is x equals 7. And now my last one is going to be 15 minus 27, and that is negative 12 over 6. Negative 12 over 6 is negative 2. Oh, man. So I must have messed up when I did the synthetic division on, oh no, I did find it. Negative 2 is a double zero. So negative 2 shows up twice. So if we get the same number twice, we are not going to write it again. So the real zeros of p of x, there's only 3 of them. They are negative 2 and 5 and 7. This negative 2 that came up a second time, we do not write it again. We only write them the first time. And that's it. I know that was a hard one, but we found all the zeros.